Hello everyone, today also we'll take examples on rationalization to make it more clear to you. For example, you have to rationalize the denominator of 2 plus root 3 upon 2 minus root 3. Now in this one, the denominator is with two terms. So if the denominator is with two terms, then to rationalize it, we have to use the conjugate. And the conjugate of a minus b is a plus b. So for the given question, the denominator is 2 minus root 3. So its conjugate is now 2 plus root 3. So we multiply and divide by the conjugate, so that actually if you look at this term 2 plus root 3 upon 2 plus root 3, the purpose of multiplying and dividing it is that we are actually multiplying it by 1 only, because this is 1. So if we multiply it by 1, we are not making any change in the given question. The question remains same. We have not altered the question. That is why we multiply and divide it by its conjugate. Now on multiplying it by the conjugate, what we have in the denominator is when we multiply a minus b by a plus b, we get a square minus b square. Now a square minus b square, a is already a rational number which is 2. So on squaring you are getting 4. And b, which is under root, irrational, on squaring it, again it is converted into a rational number which is 3. So that is why we multiply it by its conjugate of the type a plus b for a minus b. So on doing so, on multiplying the numerator by the numerator, here we have same numerators. Look, this is 2 plus root 3, here also 2 plus root 3. So when a plus b is multiplied by a plus b, we can use the identity of a plus b whole square, and the denominator is a square minus b square. Now in the numerator we can apply the formula, which is a square plus b square plus 2ab. A is 2, b is root 3. So we have 2 square, which is a square, plus root 3 square, which is b square, plus 2a, which is 2b, which is root 3, upon 4 minus 3. Now both the terms are rational. So at this point only the denominator is rationalized. You have rationalized the denominator, but you have to simplify it. So on simplification, we have square of 2 is 4, square of root 3 is 3, and this is 2 into 2, 4 plus 4 into root 3. So here you have 4 plus 3, 7, 7 plus 4 root 3. Now here these are unlike terms, cannot be added. And like terms cannot be added, cannot be subtracted. So you are left with 7 plus 4 root 3 upon 1, or you can just write it as 7 plus 4 root 3 with a rational denominator, which is 1 in this case. Let me take another example. Rationalize the denominator of 4 root 3 plus 5 root 2 upon under root 48 plus under root 18. Now here the denominator is again with two terms, so you need the conjugate. But if you look at the denominator is not in the standard form. You can express 48 as well as this under root 18. Under root 48 and under root 18 both can be expressed in the standard form. And to express them in the standard form, you need the prime factors of 48 and 18. So when you take out the prime factors, you know in square roots 2 makes 1. So under root 48 you can write it as 4 root 3, whereas under root 18 you can write it as 3 root 2. 2 makes 1. So when you express the denominator in the standard form, you have under root 48 as 4 root 3 and under root 18 as 3 root 2. Same way, you have to multiply it by conjugate. Now the denominator is of the type a plus b. So the conjugate is a minus b, which is this 4 root 3 minus 3 root 2. As per rule, you have to multiply as well as divide it by the conjugate. So you will multiply and divide it by 4 root 3 minus 3 root 2. On doing so, the numerator here, look, In this case, it is 4 root 3 plus 5 root 2, whereas here it is 4 root 3 minus 3 root 2. So you are not getting any identity. If you are not getting any identity, then it means you have to find out simply the product of these two, which you can easily do. And in the denominator, you will always get a square minus b square, because you multiply it by conjugate just to get a square minus b square. Now, the numerator, you have to find the product. So for that, you know how to find the product. You split one of the terms, multiply it with the terms of the another one. Like here, I have split this one. This one is splitted. So this 4 root 3 first multiplied by the terms of these two. Then there is plus. So 5 root 2 again multiplied by these two. So on multiplication you have, and in the denominator, of course, this is 4 into 4, 16. 16 into 3, 48. And this is 3 root 2 whole square. 3 into 3, 9. 9 into 2, 18. Now in the numerator, this is 4 into 4, 16. And root 3 into root 3 is 3. So 16 into 3, 48. This is 4 into 3, 12. 12 and root 3 into root 2. That is root 6. So this is 12 root 6, because plus, minus, minus. So 4 into 3, 12, root 3 into root 2, root 6. Then here it is plus, and here also plus. So plus. 5 into 4, 20, root 2 into root 3, root 6. Plus, minus. Here comes minus. So 5 into 3, 15. And root 2 into root 2, that is 2. So 15 into 2, 30. Now you simplify it. Like terms added and subtracted. So 48 minus 30, you are left with 18. And this is minus 12 root 6 plus 20 root 6. So these two are like terms. So this you get plus 8 root 6 upon 30. Now in these you have a common factor. The common factor is 2. So you take out 2 as a common factor. You are left with 9 plus 4 root 6 upon 30. Now 2 and 30, they can be simplified, which is 50, you are getting 15 in the denominator, and the final answer is 9 plus 4 root 6 upon 15. So you have